Hello and welcome to Unit 5, Part 4. My name is Mr. Bell, and today we're going to multiply polynomials and we're going to include some shape models. On this slide it says polynomials can be multiplied, which implies finding the product of, using the distributive property and carefully applying exponent rules. So let's get started. This problem on the left says x plus 5 times x plus 2. Well, remember the distributive property, we're going to take this x on the left side, and we're going to distribute it to both of the terms in the right polynomial. So x times x would give you a result of x squared. X times 2 would give you a result of 2x. Don't forget though, you've got to come back and also distribute the second term on the left side, which was a positive 5. So we've got to distribute that term to both of the components of the right polynomial. 5 times x is 5x. 5 times 2 is 10. Don't forget to look for any like terms that can be combined. My final product here would be x squared plus 7x plus 10. The second example here has an additional step. Notice this squared at the top. And remember that when you square something, it implies the base or the number times itself, twice basically. So in this case it says x plus 3, that quantity squared. So I'm going to rewrite this as x plus 3 times x plus 3, taking care of that squared component. And then now I can do the distributive property like I did on the first example. I'm going to take my first value of x, multiply it by both parts in the second polynomial. X times x is x squared, x times 3 is 3x. And then I'm going to take my second value, which was a positive 3, and distribute it to both pieces in the right polynomial. 3 times x is another 3x, and 3 times 3 would give you a positive 9. Don't forget to combine your like terms, giving me a result of x squared plus 6x plus 9, which is the product of that polynomial being multiplied. The last example looks a little more complicated, but it's the same concept. We're multiplying two polynomials. So I'm going to take my first term, which is an x. I'm going to distribute it to all three parts of the right polynomial this time. X times x squared, remember, is x to the third power. X times 4x would be 4x squared. And x times negative 5 is negative 5x. Then I'm going to come back and take that positive 3, distribute it to everything. 3 times x squared is 3x squared. 3 times 4x is 12x. And 3 times the negative 5 gives you a negative 15. Now carefully go back and look for any like terms. I have an x to the third power term, and I don't have another one, so that'll just come down into my answer. I have a 4x squared and a 3x squared, which combine to give me 7x squared. Have a negative 5x and a positive 12x, which combines to give me a positive 7x. And lastly, I have a negative 15 that doesn't have another like term to combine with, so that'll just come down into my answer. And there is the product of those two polynomials. Sometimes the question will indirectly ask for you to find the product of the polynomials. In this case, it says find the area. We have a rectangle. One of the sides is x minus 4, the other side is 3x plus 2, and they even give you that the area formula is length times width. Well, if I set this up, the length times the width, x minus 4 times 3x plus 2, you may notice right away that it looks like one of the previous examples that we just did. You're multiplying two polynomials. So take your first term, which is an x, distribute it to both terms in the right polynomial. X times 3x is 3x squared. X times 2 is 2x. Now don't forget to come back, take the second term, which is a negative 4, distribute it to both parts. Negative 4 times 3x is negative 12x. Negative 4 times 2 is a negative 8. And then combine your like terms at the end, leaving me with 3x squared minus 10x minus 8, which is the area of that rectangle. Here we have another indirect example of multiplying polynomials. In this case we have a triangle. It says the area is 1/2 the base times the height. So our area equals 1/2 the base, which we're going to call 10x, times the height, which is 3x plus 4. Multiplying, I'm going to go from sort of left to right. 1/2 times 10x, well, that worked out good to give me 5x, times 3x plus 4 for my area. We don't have to distribute two terms this time because we only have one term to distribute, the 5x. The 5x times 3x would give me a 15x squared, and the 5x times the 4 would give me 20x, representing the area of this triangle. The last example here will involve a circle. It says the area is pi times the radius squared, and in this case our radius is x minus 7. So let's see if we can simplify this. My area is pi times the radius squared, and our radius was x minus 7. We'll recall from that previous example that when we have a squared on a binomial, we need to expand that to say x minus 7 times x minus 7, thus meeting the requirements of what squared means. So my area is pi times x minus 7 times x minus 7. And then let's go ahead and distribute. Now we're going to leave pi out here for now, and we're going to actually simplify and multiply our two polynomials. So I'm going to take the x, multiply it by both. X times x would give me x squared. X times negative 7 would give me a negative 7x. And then my second term, negative 7 times both. Negative 7 times x is negative 7x again. Negative 7 times negative 7 is a positive 49. Let's combine our like terms to give us x squared minus 14x plus 49. Don't forget that we're also multiplying that product by pi to get our area. And in this case, I would be okay with you leaving your answer in terms of pi. If I wanted a specific detailed answer, I would ask you to evaluate for pi's value, 3.14, which is an irrational number that continues. But for now, leave it in terms of pi. All right, thanks for watching. Hope this helps.